All right. I want to say a big welcome to all of you to the Valley of the Shadows of Analytics for Finance. This is a basic introduction to artificial intelligence, machine learning, and their application to finance. Why you have to apply to finance and all of that. The Economist in 2017 said that the machine learning promises to shake up large swathes of finance. And it's been doing that. Okay. I've already introduced myself to all of you on the page. I've gotten to know some of you now. I've forgotten the class reps. So the class reps will be contacting me every time. That will help me to get to know you very, very well. I'm looking forward to you dancing in this course. The information will be put on the Sakai when everything is ready. Okay, so please get used to that part of the information. All right, Camely every time, get prepared every time. Use a laptop, okay, every time. But use the phones only when it is legitimate for you. Don't interrupt. See, you are sitting in an environment where there are people around you. There are children, there are cars, there are other things around you. If you don't take care, you are not going to be able to concentrate. But you need to concentrate. You need to concentrate. You need to concentrate. You need to concentrate. And that is the way you can enjoy and master and benefit from the module. Do not study this module with the intention of writing an exam. Study this module with the intention of becoming an analytics consultant in finance. You will see that when it gets to you, when you've understood it, when you are baptized in the sea of good analytical finance, when you are fully immersed in it, you ooze that spirit when you speak to people. So be engaged. Ask questions interactively. Ask questions. Ask as many questions. Ask questions. Don't be like if you find out that I have been talking for 3 minutes and nobody has asked me a question, you should be the one to ask a question. You should be the one to interrupt the guy. Because if you do not ask me questions, because I am so much inundated with the knowledge, I am flooded with the knowledge, I will be speaking faster without realizing. But when you stop me along the way, it helps me to explain things further and to tone down further. Okay. So let's set the ball rolling. What is the difference between artificial intelligence, machine learning, and data science and business analytics? Who can tell me? What is the difference between data science and business analytics? Who can tell me? I give marks to those that talk in class all the time. I don't like to. I record. My AI system in Zoom is able to take the names for me and then it records the marks. So when you are commenting, take a note of that. What is the difference between data science and business analytics? I'm going to go alphabetically. Adjust Apoma. I actually thought that one of you would show the video. I was surprised. I was actually thinking that one of you, just one person, will still leave the video on for some reason. Adjust Apoma, are you here?
Yes, Prof. Doc, sorry, I'm here.
I'm listening to you. Go ahead.
Well, I would say that the main difference is operating in a domain or having a domain knowledge. That's for business analytics. And then data science would be more of pipelines and applications that business analysts use.
Did you understand yourself what you said?
Yeah.
Does it make sense? Were you convinced with what you said?
Oh, yes, Doc.
If you were to tell a 7-year-old child, what would you have said?
Okay, let me take that again. So I'll say that business analysts are
Business analysts. I said business analytics and data science. Adra, are you there?
Yeah, I'm here. I'm not understanding.
You
Maybe
are?
I'll allow someone else to.
You are not able to explain it to the 7-year-old child.
Oh, okay.
Alberta Amisa. Everybody will
Hello,
talk.
Doc.
Everybody will talk here. Is Alberta Amisa here? A class rep, are you here? What is the difference between business analytics and data science?
I think for data science, it involves it's just a science, so it involves like a whole holistic approach into understanding or making reference from data. And for business analytics, it refers to analyzing like the key indicators or key movements of certain businesses using data science to make more understanding of business functions and more inference into business functions. That's what I think.
Now, very good. Somewhat nominate 2 for that for me. Okay, so let me go to I'm more interested in the negatives because as for the positives, I will later address it for everyone who has the positive. Okay. Let me go to Amy. Amy, are you there? Amy. Beta Ansu.
Hello, Doc.
Now, someone please put -3 for Amy for me. Beta, what's the difference between
Hello, Doc.
science and then machine learning?
Hello. Data science is extracting insights from data. While business analytics use data science to solve business problems.
All right, okay. Samuel, what do you think is data science and business analytics?
Well, I think that data science is using all techniques.
No, stop. Guys, I think when you are told to distinguish between 2 things, don't define them. It's one of the problems people always have. When you say, what is the difference between a man and a woman? What is the difference between a male and a female? You just bring out the distinguishing features. You don't say that a man has a head, has a hand, has an eye. A woman also has a head, has an eye, no. You are bringing a distinguishing difference. You tell us what is not. Not what is.
Okay.
What is a clear difference between data science?
I think that business analytics is just a subset of the data science. So that we are just applying data science to a specific field, that is business.
Apply data science to a specific field. You can't. You know, this same business analytics, they also call it data science in computer science, in mathematics department, in statistics department, the same thing.
Oh, okay.
It's the same thing. It's the same thing. The only thing that when it comes to the business school, we can't call it data science. So we have to call it business analytics or business science. The same thing. They are all borrowing it from somewhere. It's not coming from, business analytics is not coming from there. when you look at the details of all of them, they are all coming from statistics and mathematics and engineering.
Mm.
So I wanted to get that distinguishing features. Okay? When you go into computer science, mathematics, statistics,
Yeah.
they will never use the word business analytics.
Analytics.
They will use data science. When you come to the business school, they won't call it data science. They won't. Unless those kind of business schools that are engineering business. So take note of that first point. Second point, what is the difference between AI and machine learning? Someone nominate two for you. AI and machine learning. Let me go to Bright.
Yeah, Doc.
Yes. What's the difference?
All right, so I think AI basically deals with training machines to think and
No, you are
act
defining
in
them for me. You are defining. Don't define. What's the clear difference?
So with machine learning, I think the clear difference is you making machine learn or learn from a pool of data.
You are still defining.
Wow.
You are still defining. Distinguishing difference. Distinguishing difference. Don't define. Don't explain each one to me.
Wow. All right, so I think with machine learning, it deals with physical hardware. You making physical hardware to learn from data. I don't know if that's can do.
And then, by the way, anytime you are trying
Hello.
to make clear the differences between distinguishing differences, always connect
Hello.
them and split them. Let me ask you. Let me show you guys something. Confirm if you see my screen. Do you see my screen?
Yes, Doc.
So the blue one is B. And then the pink one is A. What is the difference between A and B?
A is a subset of B.
That's how you always define things when you're distinguishing them. If you didn't tell me that A is red, is smaller, is this, that's not what you said. And that B is blue, is bigger, that is definition you are giving, not a distinguishing difference. But this second one you just said is the perfect distinguishing difference. A is a subset of B. It splits them. It makes them stand out. It makes them explicit. Opele, Samuel, do you get it?
Yes. Get it.
Does that not make it better for you to see the difference?
Yeah.
Yeah. So now let's go back. What is the difference between AI and machine learning? Let's go to Charles Jima.
So, machine learning is a subset of AI.
It's simple. That's the first standout. Now this one
Doc,
is
how many marks for Bright, please?
This one is machine. This one is not machine. They are all machines. Okay? They are all machines. Machine learning is a subset of AI. But then there are other things that are also subsets of AI, because if machine learning is a subset of AI, there are other things that are subset of AI. Who can tell me other things that are subset of AI? That are not within the domain of machine learning? Who can tell me? This one I'm not going to pick because you guys have been doing a lot already. Otherwise, I'll pick. And if you're observant, you can see that I'm going alphabetically. Yes, sample. Eric.
Yeah, hello, thank you very much. I think robotics fall under artificial intelligence.
Sorry, someone is talking.
But I think robotics is a subset of AI.
Robotics, yes, that is one. So robotics is part of AI. That's why when somebody said machine learning is machines or it's not a robot, I was a bit confused. So one aspect of AI is robotics, apart from machine learning. What else? So robotics is one part. Ruth.
Doc, please, deep learning.
Sorry?
Deep learning.
Deep learning is already inside machine learning, so it cannot be a different aspect of AI. Deep learning is a child of machine learning.
Okay. Doc, can I say natural language processing?
So now you're coming to be mentioning them, and the one that was first, you know. You let other people talk now. Now you are saying, if it's not this one, then it must be this one, then it must be this one. So yes, natural language processing is another aspect. That is in the machine learning. What else? Clifford.
Reinforcement learning.
Okay, reinforcement learning. What else? There are two more that must come. Charles.
Well, machine translation.
And
Look, I said machine translation and self-driving cars.
natural language processing.
So what about self-driving cars?
Now, are you changing it or you are saying that it's the same as natural language processing?
No, I said machine translation from before.
Yeah, and you said, what about self-driving cars, robotics?
Yes, yeah. So that one falls under robotics.
Yeah. So you have computer vision. I thought I've taught you these things already. You have computer vision. You have natural language processing. You have reinforcement learning. You should get to know some of these things, okay, so that you can understand that what you are doing is just a microcosm of the bigger picture. Okay. All right. So you will see that this terminology will be using them interchangeably, but I decided that you will get the differences today. Our focus today is that I want you to consider yourself as an analyst. And please don't use the word business analyst, because what you guys are doing is more than business analyst. What you guys are doing are business consultants or analytical consultants. Okay, that's what you're doing. You are data scientists in the broader sense, but in the specific sense, you are business scientists.
Okay.
You got to see yourself like that.
Wow.
You see, it's never dawned on you probably to see yourself that way. So if you are a portfolio manager, you are a trader, you are a chief investment officer, okay, and you come and adopt a machine learning model, you become a business scientist.
Mm-hmm.
It's a very, very important thing to recognize. You have an addendum to what you already have, okay, in finance. So what you are going to be learning will help everyone who is into finance to know about portfolio management. So at this stage, see guys, at this stage, when I mention portfolio management and you don't know it, immediately you write it down with the intention that, oh no, I got enough portfolio management. The guy spoke about portfolio management. What is a portfolio? What is portfolio management? You put it down with the intention of going to study it on your own. Stock price prediction. If you don't know what a stock return is and what a stock price is, then you want to familiarize yourself a bit with that before the subsequent ones. We use it for derivative pricing, fraud detection, loan default prediction, corporate credit rating, bank churn rate prediction. Now, bank churn rate is just one of the churns. What is churn? You got to learn that. What is rating of corporate credit? You got to learn that. Robo-advisors. Okay, I'll give you a bit of details on some of this very soon. Robo-advisor development, okay, this is used a lot in finance, and especially chatbot development. In fact, you can actually ask a robot in a bank to advise you on your next level of investment. The robot can study your entire track record of your income activities and it will advise you without a human being coming into the picture. And all of these are machine learning driven. They are analytics for finance. So those are some of the areas we will apply our work. Okay. Let's look at today how powerful this is, an application, in real life situation. I was developing some work for some people in Leicester. Okay. This is a company in Leicester. And I didn't know about algorithmic trading. They have it on the trading floor, but I didn't know about it. But then I decided to look into it. And it's a very special way of trying to conduct trade autonomously. Warren Buffett is very good at doing that of stocks, but then you can, if you're not having that sensibilities, you can't follow his track record. Oh, by the way, he's been performing better than the S&P 500 for years, not now, for years. But some people don't have the time and the liberty to be able to do that. So you have that, that algorithmic trading to be able to do the whole analysis independent of you, for you. It can calibrate all the trading decisions in real time. I will tell you what to do for you. We will not do that because we don't have that trading floor. Then you have portfolio management. You can use the analytics, the AI, and subdivision of it, which is the machine learning, to do portfolio management. Okay? And you will notice that, for some of you will know, that AI algorithms can help financial portfolio to be able to reach goals. You can manage a risk tolerance of a customer. You can help them. For example, the system has been designed. I was trying one today, where you can tell someone who is going to retire. Suppose a person comes to you and says, I want to retire with $1 million in my savings account. What do I do now to be able to get $1 million by the time I'm 65 years? But I think in Ghana, it's 60 years. Because people are dying quickly, that's why. In developed countries where people are not dying quickly, they increase the age at which you pension. So I want to die. I want to die. I said I want to die. I want to be able to leave, okay, and after pension, have $1 million in my account. Use my age, use my current income, use my asset. And as a robo-advisor, I want you to spread my investment across assets, multiple assets that I have, so that I can reach my goal of $1 million by the time I retire. That is cool. And it will calculate everything and it will tell you what to do. Put this into that at this time, put this into that at that time, and it will do all for you. Is that not cool?
Yeah.
That's cool. Okay. Don't worry, I know some of you want to know how you can be earning, how you can become a millionaire even whilst you are earning 3,000. Guys, I will teach you. I'm not kidding you. I'll show you. It's a very simple process. When you understand it, there's a reason why the Chinese are growing so fast. Okay, because there's a connection between language and that of behavior. In case you probably don't know, there's a connection there. Did you know that the Chinese don't have future tense in their language? Everything they have is present tense. So the Chinese, not only the Chinese, the Germans, the Finnish, the Dutch, all of them, they don't distinguish between the future, the present, and the future. So instead of saying that it will rain tomorrow, the German will say it rains tomorrow. It's not it will rain tomorrow. It is not a future thing. It is a present conditions. And the way you behave is conditioned on your language. It is not at a future time reference of language. Now, why is this important? Because how you behave is as a result of what you have been inundated with, or what you have been, programmed with. And this portfolio management is a very, very powerful thing. So sometimes a person says that, how on earth can I become a millionaire, in 15 years? Yes, in 15 years, without not changing my, majority of my lifestyle. You're still going to enjoy everything with that income. You will also use it for fraud detection. Where do you normally get fraud detection? You can tell me, where do you normally get fraud detection? Can you tell me places you can get fraud? Oh, by the way, everything I'm talking about is part of your dissertation, in case you don't know. All of these are your dissertation topics that I mentioned. In case you are thinking about dissertation topic, everything here. Where can you get fraud? Let me go to the next person. Where can we see fraud? Della Akakpo.
Yes, Doc. Online payments.
Online payment.
Yes, please.
Good. Online payment. Such as what? Give me an example.
Paying for something on an e-commerce website.
Like what? Give me an example. Give me an example of a particular e-commerce website you mean.
Okay, probably buying a mobile phone from the Apple website.
Good. Where else can you find fraud? Or can you detect fraud? Or where else does fraud occur? Eric Kumi?
Prof, in the banking and the financial sectors.
Okay. Financial sectors like which one apart from the bank?
Let's say the microfinance agencies.
Good. So you got to start thinking about your applications, okay? Because this is what we look at real data set, and then how those real data set has been used to detect fraud within a profile of individuals, which is purely a thesis. Okay. And all the possible codes, Python codes that you can use to be able to come out with that. So what does it do basically? Fraud detection. You can battle every fraud detection in a financial transaction. Now, one of the places that you can get some of these fraud detection, you see, you can't control a lot of fraud detection in crypto market. You can't. But particularly in the banking section, particularly in the telecom section, okay, particularly in the transactional trade section, where you trade goods, you can detect fraud. Because what the machine learning algorithm will do is that it will scan a lot of the database, okay, and then it will detect some unusual activities. It will then calibrate security threats and flag them quickly. You don't need to check the risk profile of the person. It will do that. So if a person is likely to do money laundering, it will know. And I can say that, no, there's a possibility of money laundering, okay, for this. And so let's dig into it. These systems have already been put in place. If you know how to do that, you can write a thesis to even advise your management to be able to use that. Next one. I've already explained this, okay, to all of those that I've seen. So let's look at the types of machine learning. This is just a recap. In case you haven't done it, it's just a quick recap of the machine learning types that we have. Remember, machine learning is just a microcosm of artificial intelligence. We also have reinforcement learning. We also have computer vision, okay? And then you have robotics and other ones. Within the machine learning environment, you have supervised, unsupervised, and reinforcement. Now, please note that this reinforcement is not the same as the recommendation systems. Okay? It's not the same. Because reinforcement uses more of learning by experience, or learning from experience and associated rewards. People normally react on the basis of rewards and punishment. For example, if you tell your child that if you eat the chocolate, if you eat the food, I'll give you chocolate. That is a reward. Or if you don't eat the chocolate, I'll cane you. That is a punishment. Okay? And based on that, that child will now know the results for subsequent ones that will come. Now, in reinforcement learning, an agent will observe the environment, select, perform an action, and then that agent, because he's done that, you get a reward. Once he gets a reward, he now knows that if he performs those particular actions, the net effect of that will be a reward. So if he wants a reward, he will do that action. Otherwise, you will get a penalty in the form of a negative reward in return for not doing that. So it helps. That's why a person can control a robot and say move backward and say stop. Okay, and the robot will still listen to the first, the second, and the third law of robotics because that robot is using a reinforcement learning. Now, for supervised and unsupervised, one of them is data-driven. Okay, unsupervised. You guys have done that. For supervised, I hear you are now doing supervised learning. Is that correct? Or you've done it also?
Supervised. We are here to meet.
So you guys have not done anything on supervised learning at all?
Last semester we did unsupervised.
So it means you haven't done anything supervised learning at all?
Maybe, unless maybe regression, linear regression, if it's typical.
Somebody, Charles is saying that why are we not doing algorithmic trading? Chief, the reason is that sometimes it's good to go to the trading floor to appreciate it. That's all I'm saying. We are not on the trading floor. That's why. Okay, Charles, I hope you understand. All right, so guys, so let me get it. So you guys don't know about things like support vector machine, decision tree, random forest, lasso. You don't know, right?
No.
No problem. That dessert. So okay, it's going to be exciting. It's going to be exciting. Say it's going to be exciting.
It's gonna be exciting.
Because most of you are going to use this thing for your thesis, are you not?
Yeah.
So how can they be telling you to do something in your thesis when you haven't learned them? Or you are not going to learn them. So the idea is that you're not going to. Yeah, this is not good. All right. I'll make you teachers of this. So you become teachers of these things. All right, so look at all of them. Let's look at a bit of the Python codes that you use and Python commands that you use. For data representation, a lot go with NumPy and Pandas. Okay. For statistical analysis, we'll be using SciPy, scikit-learn, we'll be using stats models, a lot of the stat models. And we'll be using the Keras, However, we will focus on TensorFlow instead of the Piano. So use more of the TensorFlow. For visualization, Matplotlib library and Seaborn are very common. Some of you have used it before. And if you want to force install a particular package, which is not there, you want to force a particular package, you can use the pip install. Normally, you bring an exclamation mark in front of it before you do the pip install. We'll learn all of that. But the most important thing I want you to know today, before we go today, is the steps in machine learning modeling. The steps in machine learning. And when you're writing your dissertation and your thesis, these steps are all packed inside the data analysis section of your work. When you come to methodology, And then you go to analysis. That analysis part of your thesis, all of these things are there. By then, you would have already defined these methods in the methodology, and the analysis is just demonstrating them. What is the first step in machine learning modeling in the financial sector, in the ecosystem of financial sector or financial activities? Well, the first step is to define the problem. Identify the goal of the model. Define the problem. Please note, this problem you are defining is not a problem statement you would have defined in your research. So in your research, you would have defined a problem statement. But in your problem definition here, you will specify the model problem. The model problem. And we'll look at an example of that. So that's the first step, to remove the dress and the skin and show the skeleton of the problem. That's the first step. The second step is to gather data and load the data and load the packages into the software, the Python software, the Jupyter Notebook. Okay. So you will load all the libraries. Sometimes these libraries are called packages. And you will load the data set. Now, the data set must be a data set that has already been sort of cleaned. You will clean it again, but at least they are better sort of cleaned. That's it. You load the data set. Then you will do something we call preliminary works, which is known as EDA, exploratory data analysis. So you will generate contingency tables. You will generate data visualizations. That's why you use a Matplotlib and then the Seaborn. You will generate descriptive statistics, the mean, the median, the mode. Okay. Then all the spread, the standard deviation, the variances, the ranges, the kurtosis, the skewness. The minimum absolute deviation and the coefficient of variation, all of them will come when the need arises, especially when you are dealing with stock prices. Those are exploratory. You look at them. You look at all of them. And then you prepare your data properly. You clean the data properly. Availables, unavailables, missing values, feature selection. Which particular features are needed? If you have 30 different features and you need only about 7, what criteria will you use to torpedo some of your variables? This is a general thing. It's not going to happen now. The first 1 month, we are not going to do this. This is just to let you know the steps in which machine learning goes. We'll come to this thing after 1 month. And then you can transform the data. After you have used feature selection to select the right features that will be used to handle the target variable. You transform the data. Why? Because sometimes they are not normally distributed. And in order to make them normally distributed, you got to log linearize them. You got to do scaling. You got to do several other things. Then from there, you will now go to evaluation of the model. So that's why you bring all the machine learning models into the picture. You will split the data into training and fitting, training and testing of the data, okay, using several cross-validation rules you use. You will identify the key evaluation matrices, whether you are going to use, LSTM, long short-term memory, whether we are going to use ARIMA, auto-regressive integrated moving averages, whether you are going to use decision trees, lasso regression, range regression, elastic net regression, random forest, support vector regression, decision tree, whatever you're going to, this is it. This is where you got it. And then you want to check whether each of these things you are using which one is the most effective. You validate using the R squares and other, reliability tests to check which one is the best one to use to do the prediction. And then after having identified that particular one, you will now go into hyperparameter tuning, where you will tune in to the specified regression. I always say the hyperparameter is just like, we'll go through some of these things. It's just like when you put a food in the microwave, and we know that you can press 4 minutes, but then you can tune it as to whether it should make it slow cook, medium cook, or high cook. That sort of tuning is the same thing that you would do with a hyperparameter tuning. The common approach for this is known as a grid search. We shall look at that. And then finally, since you have done your work on the training data, you can now perform the evaluation on the test data. You will now create an intuition from your results. You save the data and deploy it for further use. So these are the real practical application of the machine learning in finance. We'll look at all of this in finance. That's a blueprint. And these are a bit of the details of each one of them. For example, in the definition of the problem, you define formally and informally, list all the assumptions, the benefits of solving the problem, how the solution will be used, how the problem will be solved using the domain knowledge. You train the model. And in case you probably are yet to know, guys, training a model, first of all, what is a model? Who can tell me? What is a model? Let me go to the next person. What is a model? Eric, have you spoken? Ezekiel, back on. Eric, Kumi, what is a model?
Doc, I've spoken. No.
Okay. But you can speak again, you know that. The way he said I've spoken, it's like, don't kill me. Don't kill me, I've spoken. Yeah, where's the other guy? Ezekiel.
Hey, good evening, Doc. I'm here.
Ezekiel, stop. Hold on. I think some people have now all of a sudden changed their name. Daniel Lamte, have you spoken?
Not spoken, sir.
You spoken?
No, I have not.
Yo, so tell me, what is a model?
I would say a model is basically an algorithm, which is a set of. Sorry, come again.
It's simple. What is a model? It's not an algorithm.
Okay, I'm trying to define it in the way I understand it. So
yeah, but you are using another thing. Algorithm is a procedural analysis. Algorithm is a step-by-step procedure, instructions on how to execute a task.
Okay, I draw similarity from that in the sense that with a model, you've also fed it with a set of instructions, and then it kind of follows through that instruction to give you what do you call it? I mean to undertake a task.
So is a model true or fake?
Sorry, come again. It's a model.
Is it true? Is it true? Is it true or false? Is it real or fake? Yes, who can help him? Ezekiel.
Yes, Doc. I'm thinking through it. Yes.
Completely. Let me go to Abudu. Abudu.
Yes, Doc, I'm here.
Go ahead. What is a model?
I think a model is
I want you guys to take your mind off machine learning. I think you guys, your mind is becoming machine learning too much.
it's a representation of data.
I like the way you started. I like the way you started because that's really good way of starting. A model is a representation of reality. As a model. Someone give a 2 for me. It's a representation of reality. That's a model. Now, because it is only represent reality, because it's only representing a reality, you can change it. See, let me give you an example. Let's say that somebody, you want to manipulate an aeroplane, but you cannot manipulate the aeroplane because the aeroplane is too big. So what you decide to do is that you create something like the aeroplane in a small fashion, which you can manipulate. But in the process of manipulating that small thing, you can manipulate the actual thing. It's easy to manipulate the real thing. So sometimes in a world of simulation, if soldiers go on a war and then they are trying to simulate how the enemy, if you check Netflix and you saw the way they killed Osama bin Laden, they simulated the process because they got to know where he was. Then they targeted the building, the area. They monitored that place for days and weeks, everything. And then they formulated, they could not see inside, but they could not see inside, but they can see on top because the drone is on top. And so they need to know which people are also in there. But when they enter the room, they don't know whether children are there or children are not there. So they have to simulate all possibilities. They created a model. So when you have a model, you can train the model. So a robot can be trained because a robot is a model of a human being. You can train the model to recognize certain things, to recognize that this is a card, this is money, this is a hand. So the robot will be recognizing the patterns to be able to use that robot because it's not able to recognize the patterns. You cannot use the model to predict. You cannot use that model, which you have trained, to classify. When you bring another set of things to it, it will be able to distinguish it because it will know. One of the challenges robots have had, and when I say robot, not necessarily robot, it can even be a normal computer, is distinguishing between colors. Colors. Very difficult to classify that. So you got to train a model. And in the process of training, that's why somebody said algorithmic trading, whether that's good. So you do that by feeding the model with data. Data. That is why in most of my programs, I say that data is oil. Artificial intelligence is a new electricity in town. And you will notice that data is necessary. The more data you have, the better the predictive power of the model. And then after doing that, after training the model and feeding it with the data, you can alter the parameters based on the patterns and then cut down the errors in the process. This I just spoke about, you guys will do. You will train your own model. Okay? That you can use for the financial managers and for accuracies to be made. So that's the first thing about the definition of the data. Once you've gotten it, you load the data and the packages into your software. Most of these things you see on your screen are some of the ways of importing data. So there are a couple of tickers. We talk about tickers, when we get to the stock market. Guys, by the time we finish, you guys will start trading. okay, not trading, but you start, putting money into stocks. Oh, by the way, the stock exchange in Ghana is inefficient, and then put it that way. So you want to go to stock markets that are efficient. And this is for some good reason. You can, buy stocks in foreign lands. You can buy stocks of Amazon. You can buy stocks of, Tesla. Some of these things are going down, but you can buy stocks of Google and things like that. In this case, you can see that there are stocks of S&P 500. That is there. The Dow Jones. Okay, that is also there. And then you can also see stocks of the exchange rate between the dollar and the Japanese yen. The exchange rate between the dollar and the US, the dollar and the pound sterling. You can see them here. So some of these data are already in Yahoo Finance, and you can extract those data. Some of them are also in Fred, another database. You can extract those. So you will learn how to extract those. Okay? They are very simple. And then once you've extracted the data, you can now do your exploratory data analytics. Most of the things you do, you check a bit of information about the data. Okay, you check the dimension, you check the description. The description will give you all the summary statistics of the data. You will do a lot of summary distributions, and guys, you will now master and understand that the mean that you have been using all along, there's something to the mean than the mean that you know. That mean is not just mean as average. No, there's more to that mean. And you now understand the power of that mean when it comes to financial analytics. You will learn about data visualizations. You will use a couple of data visualizations. So you guys, let me just get this clear. I taught you statistics, but we never used Python, did we?
Dog, we did.
We did. I didn't even used to break a crowd. So what kind of Python activities did we do? Did we do regression?
Yeah.
Is that why we did Python?
Yeah, we used Python for question. Multiple.
So it was basically OLS, linear regression.
Yes.
Okay. All right. So you should know the difference between training and testing data. I've just given you a table here that will tell you the difference between the two. Why do we need to have the two? Okay. We train a model and fit the parameters on the training data. We use that. But then when you want to evaluate the performance of the model, so let's say you have a OLS regression, or you have lasso regression, or ridge regression. Okay. When you want to tell, because the testing data is 20% of the data, and that testing data, you didn't use it at all. So if you are telling me that your model you have is good, if I give you something that wasn't there, you should be able to apply it to this testing data, and then the testing data can be used as an evaluation metric for your training that you did. So it's like when you say that some teachers have taught you, so all your teachers are 12, they've taught you. Okay, good. They set an exam for you, you did it. Okay, good. Now we bring 2 external examiners. They are not 12 people. They are just 2 external examiners. They now come and test you. If you are able to pass, then it means that what the teachers did was what? Was good. It means that the teachers have taught you well. It means that whatever teaching the teachers have done, the 12 teachers have done to you, they have done some good job. Because these external guys have confirmed what you did. So the testing is used to validate the training. And as you can see here, typically the training is, my computer is hot, Papa. The training is 70 to 80%, while the testing is 20 to 30%. Then after that, you clean the data and do feature selection. Okay, we'll look at the details of this in the process, but please understand something the features, they are used in the model, they are used to train the model, and they can affect the performance. So if the features are bad, irrelevant features, they can affect the performance. So that's why we do feature selection. But feature selection is where you try to identify which features, which independent variables, in case it's a regression, contribute the most to the predictive arrangement of the dependent variable. And it is very much used in supervised machine learning than in unsupervised learning. When you select proper features, you can reduce overfitting. Okay? You can make the model decide, not based on noise or complexity. When the model is deciding based on noise, that is overfitting. But when you give it that choice, it's not. You can also improve the performance of the model. The R square can shoot up when you do feature selection. I'll show you all of this. These are just things that will come later and you will understand later. You can reduce the training time if you do feature selection. Imagine the features are 30. You cut them down from 30 to 7. The training time will go down. We'll use a certain function in Python, okay, sklearn. It's under sklearn. We'll use that to check for irrelevant features and deal with them. The next thing is to transform the data. I've explained this already, but the transformation, yes.
Doc, sorry. Last semester we did something about dimensionality reduction. Is it related to feature selection?
No.
Looks like the explanation sounds similar.
Yeah, it sounds similar. So the dimensionality reduction, you can do that using principal component analysis and other things. Now, what the dimensionality reduction is, that it doesn't consider whether they are dependent variables or independent variables. It's just variables. Then you try to whittle down those variables, of course, knowing which one is loading better, and then you are able to squeeze the variables down. But there is no dependent or independent variable. With feature selection, the focus is purely on the independent variables alone. So with feature selection, you will have a dependent variable, and then you are going to do that. Other than that, the process is the same.
Okay. Thanks.
Once you have reduced the data, you can transform it. You can transform it by rescaling. What does that mean? It means that some of them are in dollars, some of them are in kilograms, some of them are in other units of measurement. So you can scale them. You can scale them. You can scale them so that everything will be in a kind of a common unit of measurement. And the Python code for doing that is called Minimax Scaler. We use that to do the scaling. Then you can standardize it. Okay, standardizing it, we've done it before. I think I did it with you guys. You remember when we were doing principal component analysis? We did standardization where you convert them using the Z value. You guys remember?
Yeah.
You convert the whole thing from the raw value to the Z values. That is standardization because it's normally distributed with a zero mean, as you can see here, and a constant.
Yes.
The package for doing that is standard scaler. And then you will normalize it. How do you normalize it? You normalize by rescaling. So you already scaled, but you rescale each observation to have a length of 1. And when the data is sparsely populated, like the data is very, very scattered, sparsely populated, then normalization by rescaling is useful. So these are the steps you will use before you come to the evaluation of the model. You train the model with 80%, you test the model with 20%. Remember, training the model is actually generating the results. Testing the model is predicting that the model is effective. Okay, and therefore it can be used for further work. Now, remember that at this stage, there will be a lot of models that you will do. This is where we'll go through these models one by one. Some of them, by the time we do it, You have already learned them, so no problem. Okay. Now, the final thing is to, yes, Della.
Prof, please, the 2 slides before this, I noticed with the code snippets for the standard scalar, you did a fit and you did a fit transform. I thought the fit transform combines both the fitting process and the transforming process.
You said you thought the fit transform does what?
It does the fitting and the transformation. So you don't need to do a fit before you do a fit transform.
Is it the standardized or the normalization? Which one are you talking about?
The standard scalar.
Where's that? Oh, yeah, this one.
Actually, yeah. Yes, please.
Okay. You said it's done what?
I noticed you did the fit before you did the fit transform.
Okay.
The
Oh,
fit
are you
transform.
talking
I
about
thought the
this
fit
one?
transform. Yes, please. Yes, please. That part.
Where I've done the scalar equals to standard scalar.
Yes, please.
And then I did a fit transform. But why did I do a fit transform before? I did a standard scalar first.
Yes, but then okay. So I'm asking, doesn't the fit transform function combine the fitting process and the transformation process?
Yes, it does.
So do we still need to do the fitting before we come and do the fit transform?
No, but the thing is that when you have fixed, when you have standardized a thing using the scalar. So watch it here. When you did that standard scalar here, you renamed it as scalar. Then you come here and come and do a fit transform on this. But you are actually, you have to do it on both. You have to do it on the raw data and then the transform data.
Oh, okay.
So this first one is doing it on the raw data, and then the second one is doing it on the transformed data.
Okay.
Yeah. Well, in most cases, you will not do both. You do one.
Right.
Yeah. These are just giving you all the possible codes that we do. But in most cases, you will not do this middle one. You do the last one.
Okay. Right.
Yeah.
Thank you very much.
Yes, Seto.
Yes, sir. So while you were going through this process, it sounded like you moved from still on the number 4, the previous slide. So it sounded like you will move from maybe rescaling to standardization to normalization. Are they like, is it a process you go through, or is one you choose from the 3?
It's one you choose.
Okay.
It's one you choose that you want to deal with. In fact, for some of them, you don't need to normalize at all. For some of them, you need to normalize, you don't need to rescale. So it's not step by step that you got to go through all of them.
Okay, all right, thank you.
They are all part of the transformation process. You got it?
Yes, please, thank you.
All right. From there, you go to the evaluation of the models. Okay. Evaluating the models, we've said that you select a machine learning model. In fact, for this, our course, you will do 18 different machine learning models. Don't worry. The software can run all of them at a go for you, so you don't have to have a problem. No, don't worry at all. We'll put the model all there. It will run them straight away, OLS, straight away, Lasso, straight away, ElasticNet, straight away, Rage, straight away, Random Forest, straight away, Support Vector Machine, straight away, MLP, straight away, LSTM, straight away. All of them will come, boom, 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 boom. And it will also generate their, errors for you, their evaluation errors for you. So you look at their MSE, which is a mean squared error. You can look at their MINE, which is a minimum absolute error. You can look at all of them. Root means squared error. All of them, it will generate all of them for you. Then we'll compare the errors. So we'll do that. But you have to identify which evaluation metrics to do. And we'll look at how to identify, because that's a skill. The skill of which evaluation metric should I use. And there's no particular way of saying that this one is always the best, so it will be the best for my data. So Random Forest might be best, but subsequent times it will not, depending on the nature of the data. The data can be balanced or imbalanced. and that can affect the situation. So once you've done the evaluation method, you compare the models. And we shall compare that. In the stock price prediction, we'll compare models there. And then after that, we'll make a decision on which model we are going to go for. And then based on that, you use that model to do your prediction. Now, some of the models will be having polynomials or quadratics. Some of them, will handle all of these if the need arises for such a situation. You don't always have to do hyperparameter tuning. I've said it before. I've given an example of a microwave. But for most cases, you do hyperparameter tuning. The best combination of hyperparameters of a model can be treated using a search problem. And this is the model tuning. And it's one of the most important steps when you're doing the model development. What are hyperparameters? Remember, the hyperparameters are not parameters. Take, for example, regression. A regression has got beta parameters. There's a clear difference between the hyperparameters and parameters. Please go and find out. It will come after 1 month. But go and still find out that there's a clear difference between hyperparameters and parameters. The hyperparameters are outside characteristics of the model. So they are not. The parameters are within the model. And these outside characteristics or the external features of the model, they are used to control the training process. And like I said, they are like the model settings. They are set before you train the model. Before you train the model. I mean, it's just like the microwave example. Before you press start for the food to be microwave, you have already set it to be high, medium, or low. You've already set it. That is a hyperparameter. It's not within, it's outside the model. The beta parameters are within, which you are looking for in the process. So this process is known as hyperparameter tuning. It is achieved by using something called a grid search. If you have seen what a grid is, sometimes, I mean, those in a power plant will tell you a lot about grid. Please read about each one of these terms before we meet. Like I said, this very example, we are not going to do it now. We are going to do it after 1 month's time. But start reading about each one of these slowly before we get there. Because what we are going to do from next time going is going to be more of the other one, the money, how to make money, how to become a millionaire in a financial sense, or how to help your clients to make more money. That's what we're going to look at. We do a lot of machine learning modeling. Okay, so these are other things apart from the grid search. Okay, they are random search, Bayesian optimization, and hyperbrand. All of these are examples. But the key one we shall use is a grid search because it looks for all possible combinations of a predefined hyperparameters. Okay, after that, you finalize your model. You run the predictions on the test data with a trained model, okay? And then you select which model you want during the training steps, and you evaluate it using the test set. Now, the testing data or the test set allows you to compare different models unbiasedly. You base it by comparison in the data that was used in any part of the training model. You now use the other part for the testing. Now, when you use the testing, the test results of the polynomial model or quadratic model or anything can be shown. These are just general things. When we come to the specifics, you will appreciate it more. Okay. Apart from the model performance, the other things you can do, you can consider selecting a model, such as using a simplicity, interpretability, and training time. All of these things can affect the way the model will behave. And sometimes you go further to check some of these things. Finally, you can you should make intuition for what you have done. Consider the entire view of the approach that you have used to solve the model. Consider all the models you have used, their pros and cons that you have done, the variables you've selected, and then make sense, practical sense of the result. Write an executive summary of the result. Save your work, of course, deploy it later if you have to use it. And then you can now take your results to the board of directors and tell them what is the best thing they should do. In fact, people have made a lot of money by using, especially stock price prediction, by using these executive summary to advise several people. I've put some topics here, videos here to just go and watch. That will help you to be able to understand each of these steps we have looked at. But we'll look at each of them as well subsequently. Ladies and gentlemen, that is your first encounter with machine learning. For the next 4 months, this is what we are going to do. We are going to look at certain interesting things in financial analytics. One, we are going to consider the first aspect of the time value of money. We'll consider the present value of a payment, the future value of a payment. We'll consider ordinary annuity and annuity due. Don't worry, if you don't understand, I'll explain all of this in the process. We'll consider a perpetuity, ordinary perpetuity and perpetuity due. We'll consider all of that. We will then go further to look at amortization and how all of this, we use Python, and how amortization actually helps. We'll consider what a person can do to be able to become a millionaire in 15 years' time. If the person is earning $3,000, it doesn't matter whether it's $3,000 or 3,000 cedis. As long as it's 3,000, it doesn't matter the currency. 3,000 or more. Okay, we'll look at that. Look at how, guys, you got to learn something. There's a book, by the way, it's not here. It's called The Intelligent Investor. The Intelligent Investor. And there's a book also called The Compound Interest. It's the greatest of all books after the Bible, The Compound Interest. So you learn that. Then we'll look at capital budgeting. We'll look at certain things you have been buying that you are not supposed to buy. We'll look at the profitability angles of certain things you do. We'll look at the internal rate of return of certain things you do. Look at the net present values of certain things that you do. The payback period of certain projects that you do that you are not supposed to do. But others are doing it. Or things that you're supposed to do that you're not doing, but others are doing. Things you're not supposed to do that you're doing that others are not doing. We'll look at that. And how all of these will count towards your net worth. We'll define what goes into net worth of a person and why so many people have not been able to achieve the net. You know what I do is anytime I talk about this, sometimes people start wondering. So since you know all of these things, are you telling me that you have gotten them? What do you think, guys? What do you think? That because I'm teaching this, doesn't mean that I've been able to apply these things and then my life has been better. What do you think?
You're a billionaire.
Oh, dear me.
A
Until what
multi-millionaire.
you know becomes what you do, you don't know anything. I want to repeat that. Until what you know becomes what you do, you don't know anything. Until what you do benefits you and someone else, what you do is useless. Why? Because the evidence of knowledge is resolved. Write it down. The evidence of knowledge is resolved. You cannot copy me because I have been able to apply, tested, estimated, achieve the results. That is why I have the audacity of Dead Cockroach to actually talk about it. So I can teach you. But I'll teach you I'll teach you in the world of according to this course, not in the world of too much practicality, because we are time bound for this course. So that is the, any question, ladies and gentlemen? That brings us to the end of the entire
Kabuldo.